So now you can do calculations with photons, right? But now we've got two theories to describe the behavior, the phenomenon we call light, right? We've got a wave theory, we've got a photon theory. And the thing that you need to understand about this is that when Einstein proposed his photon theory, everybody thought it was just a bunch of bunk, okay? Even when they were gathering data that supported his theory, people thought it was total bunk. And the reason is that light had been behaving like light refracted, diffracted, interfered, did all these things that only waves could do. And so they just knew that it couldn't be a particle, right? Now, the answer is that light sometimes acts like a wave, sometimes acts like a particle, okay? So let's look at these two descriptions here, okay? And this animation, those two animations, I won PowerPoint of the year in like 2003 for those animations, right? Let's make a little chart here, okay? In light, if we're describing the phenomenon color, okay, with light, the wavelength of the light changes, right? Okay, so small wavelength is blue light, right, and large wavelength is red light, right? This is all pretty. This is what we're used to, right? Okay. And for brightness, it's the amplitude that changes, right? So a dim light has a very small amplitude. Remember, amplitude is this thing right here. Okay, wavelength is this thing here, right? That's lambda. Okay, here it's small because it's, well, it's small, right? There it is, right? So dim light has a small wavelength to it, but bright light's got a bigger wavelength, right? So the electric fields are bigger that make it up. The magnetic fields are bigger, right? That is how we understand waves, okay? Photons, it's slightly different, okay? Color is energy per photon, right? So this is why, as we get to the blue end of the spectrum, the high energy end, right? Because it's E is HF, right? When the frequency goes high, when you get blue light, right? We've got more energy. Ultraviolet is even more than that. Ultraviolet gives us sunburn, right? X-rays, people walk out of the room when they give you X-rays, right? So we know that at least as far as chemicals and interacting with molecules, that photon theory is our best way to describe it, right? Okay. So remember, radio waves are pretty safe, but X-rays, yeah, not so safe, right? Okay. Brightness is not the amplitude of these things. Every photon of a particular frequency has the same energy, right? It's just, for bright, it just means it's a lot of photons, okay? So many is bright and few is dim if you don't have very many photons, right? Okay, this is very important because Einstein proposed an experiment. That's the next thing you got to learn about. When he said that light acts like a particle, he said, do this experiment. If you do this experiment, you'll get this result. And that will support my theory. And the difference is, does the energy of the wave, does it depend on the color? Or does it depend on the brightness? In wave theory, it's the amplitude that matters. Frequency doesn't matter so much, right? It's the amplitude that gives a wave energy. In photon theory, it's the color that gives it energy. And Einstein said, look, if you do this experiment, you're going to find that color predicts the energy of light, not brightness. Okay?